Okay, a process that's often done in labs or by lab techs is dilution. In other words, I take a concentrated solution and then I dilute it. Of course, we need to do some mathematical treatment to it, so I need to come up with or start with a concentration that I know and a volume, and then end up with a certain concentration and a volume. And there's a formula that's been generated that helps us do that. So here's the formula. So the first molarity multiplied by the first volume is equal to the final molarity multiplied by the final volume. It's a fairly, I guess, simple proportion-based formula. To use the formula, of course, with any formula, you need to know all but one of the variables. So I might know the molarity of what I'm starting with, I might know what molarity I want to end up with and what volume I want to end up with, and maybe I'm looking for how much of that first solution I need in order to make up this. Or maybe I know this, and I know this, and I want to know what the final volume is. But it's like any other formula, you need to know all but one of the variables. So let's try a couple questions. So here's one. Reaction calls for 100 milliliters. I'm just going to change that right away. I guess I could leave it in milliliters, but often it's a nice process to make sure that you change any of your numbers into sort of the appropriate units. And we're always using liters in formulas, so maybe it's nice to just change that right off the bat to liters. Reaction calls for that of this molarity. The only sodium hydroxide on hand is at 3 molar, so they want to know how many milliliters of the 3 molar solution I'll need in order to produce that final, this volume of that molarity. So my formula is molarity to start with, volume to start with is equal to final molarity multiplied by the final volume. It might be a good idea to identify these things. So if the reaction calls for this stuff, this must be the stuff, the final stuff. So this would be the second volume, this would be the second molarity, and this one here would be my first molarity. And now it's just a game of plugging in the numbers. So I want to know what the first volume is. So the first molarity is 3.0 molar times V1, I don't know, is equal to this final molarity is 0.500 molar times the final volume is 0.1000 liters. Okay, so if I'm looking for V1, and I probably could have done this to begin with, if I'm looking for V1, I could have rewritten the formula solving it for V1. Or like I did this time, I plug numbers in and then solve. Either way is fine. So I'm looking to find V1, I'll divide everything by this. So V1 is equal to 0.500 molar times 0.1000 liters divided by 3.0 molar. Notice that the molar and molar will cancel out, so my final volume will be in liters. Okay, so off to the calculator. So I'm going to go 0.5 times 0.1000 divided by 3 equals. And I come up with 0.01 and then repeat 6. So I'll just put a bunch of 6's here. Now the question initially asks for how many milliliters. So I guess I probably should convert this back to milliliters. So that would be 3, 1, 2, 3. So it would be 16 points. I also have 2 sig figs here. 2 sig figs. Oh, let me erase that. If I'm going to round that to 2 sig figs, it would be have to round to this one. So it would be actually 17 milliliters. So in other words, if I want to get 100 milliliters of a 0.5 molar solution of sodium hydroxide, if I'm starting with 3 molar, I'm going to put 17 milliliters of that 3 molar sodium hydroxide into a volumetric flask, and then I'm going to fill it up with distilled water till it gets to 100 mils. So 17 of those mils will be of the more concentrated sodium hydroxide, and the rest of the milliliters will be pure water. Okay, so that's a dilution question. Here's another one. What volume of sulfuric acid would you need to react with this and this? The sulfuric acid is 0.5. Okay, so just a minute here. I don't know if this is I don't think this is a dilution question at all, because I'm not diluting anything, I'm reacting. As soon as I see something like react, that's not a dilution question. Toss that. Can't do that one with dilution. Perhaps if it was a one-to-one relationship, I might fluke out and get the dilution, use the dilution formula and get it right. But if it's not a one-to-one relationship, not going to work. If it says react, I'm on the bit to do stoichiometry. I can't use the dilution formula for that. Not a dilution question. Let's try another one. Okay. Well, disposing of acid bases, you're told to dilute, dilute, dilute. When you dump the acid or a base into the sink, pour tons of water down there with it. So if I have 50 mils of a 3 molar solution of hydrochloric acid, and I dump it down the sink with 10 liters of water, what will the concentration of the acid be once I've dumped all that water in? That's a good dilution question. Notice that there's no chemical reactions happening. So this will be a M1V1 equals M2V2. They want to know what my final molarity is. So maybe I'll just solve the formula for M2. So it'll be M1V1 over V2. Or, if you're like me and you like to have the unknown on the left, I'll just swap their places. And again, like I said earlier, if you have trouble manipulating formulas like this, get some help with your instructor. They'd be glad to help you. Now plug numbers in. Oh, I didn't identify up here. So initially I have this volume, that'd be my V1, and this is the initial molarity, so that's my M1. And here's my final volume, V2. So now I just plug all these numbers in. So M1 is 3.0 molar. V1 is 50 milliliters. Let me change that again to liters. Okay, so we've got molarity, first volume, divided by the final volume, which would be, I guess we're including the 50 milliliters in the 10 milliliters altogether. So 10.0 liters. So if I take that to my calculator, the final molarity of that solution, once I've diluted it with a ton of stuff, will be 3 times 0.05 divided by 10.0 equals. So the molarity would be 0.015. The liters cancel, molar. So 0.015 molar, that would be the concentration. And that would be a very, very weak solution. Still slightly acidic. It would probably still turn some blue litmus paper red, or slightly red, but I guess we'd have to test that. But still slightly acidic. So always good to throw in lots and lots of water when you're dumping acids or bases into the sink. Now, just a sort of a final question on this dilution kind of thing. So we've been diluting things. Could we make something more acidic? So, for example, how could you make something not acidic, but more concentrated? So say I have something that is 3.0 molar, and maybe I wanted to get that to be 6.0 molar. How could you do that? Maybe just pause the recording for a second and think about it. How could you make something more concentrated? Fairly easy to dilute something, but to make something more concentrated, Yeah, how would you do that? I guess we wouldn't want to change the solute. We'd want to keep that, but we'd want to change something to do with the solvent. We'd really want to get rid of some of the solvent. So how would you do that? Interesting kind of question. Maybe a little bit of evaporation, or there's probably other techniques, but you could conceivably do that, get something that's more concentrated by doing evaporation or some other technique like that. Okay, so that sort of concludes our discussion of dilution. Here's the big formula that we use. We find the product of the initial molarity, initial volume, and equate it to the final molarity and final volume. If I don't know one of those four things, I can solve for it.